Thank you for another session, Coaching Smart. After we are done with the graphical method, we are starting with a simplex method. Under simplex method, a linear programming technique in which we start with the initial feasible solution and we end with optimal solution. It is an iterative procedure in which we proceed in a systematic step from the initial basic feasible solution to another basic feasible solution, and finally we end up at the optimal feasible solution. Help in solving a problem by giving us the best solution to a problem. Anything simplex means complex. Anything ending with X is an initiation of complexity. Terminologies. Number one is feasible solution, the set of values of the variable which satisfy all constraints and non-negative restriction of the problem. Basic feasible solution, a feasible solution to a linear programming problem in which the vector associated to the non-zero variable are linearly independent. Optimal or optimum solution, when the feasible solution given the optimum results from the objective function of the problem. Basis. The variable whose values are not restricted to 0 in the current basic solution. Basic variables, the variable which are listed in the basis vector. It is any column or a row of simplex table. Unit vector, a vector with one element being 1 and the rest element are 0. Net evaluation is the net profit or loss of one unit of a variable in the respective column is introduced, and the symbol is change in J. So the formula is change in J equals to Zj minus Zj, where Zj is the coefficients of xj variable in objective function and Zj is the sum of the product of the coefficient of the basis variable in the objective function and the vector xj. Minimum ratio is the lowest non-negative in the replacement ratio column. Key column is the incoming vector, the column which has highest negative in maximization problem and the column which the highest positive for minimization problem. Key row, the outgoing vector, the row which relates to the minimum ratio. Key element, the element which lies in both key row and key column. Iteration, it is a step-by-step process followed in the simplex method whereby you move from the one basic feasible solution to another basic feasible solution until you get to the optimal solution. Formulation of simplex method. Step followed in the solving the simplex problem. 1. Formulate the problem into linear programming. 2. Convert the constraint into equation. 3. By introducing slack variable and surplus variable. Slack variable is introduced when your equality is less than, and surplus variable is introduced when your inequality is more than. Construct starting simplex table. So you construct what we call simplex table. Then conduct a test of optimality. How do you do that? Done by computing the net evaluation. Then determine the incoming vector and the outgoing vector. Then finally, repeat the process 4 and 5 until you get the optimal solution. Now that is simplex table, format of simplex table, whereby we have basic variable, xb is the results, x1 is the first variable, x2 is the second variable, xn is the number of variables, s1 is now it's either the surplus or the slack variable. R symbolize the ratio. When you divide the basic xb variable and the key element. Problem. A company manufactures two products of milk which are fresh and sold. The company has two types of machine A and B. Fresh product takes 2 hours on machine A and 4 hours on machine B, whereas soy milk takes 5 hours on machine A and 2 hours on machine B. The profit realized on the sale on fresh milk is $3 and that of soy milk is $4 if machine A and B can operate 24 hours and 16 hours per day, respectively. Determine the weekly output for each product in order to maximize the profit. So that's the nature of the question that we expect. So how do we solve this question? Number one, solving the problem using the simplex method. What to keep in mind? Formulate the problem of the linear programming. 2. Determine the variables of the problem. 3. Determine the objective function. 4. Determine the constraints function. 5. Convert the inequalities into equalities. Construct the starting simplex table. Conduct the test of optimality. Determine the incoming and the outgoing variable or vector. Repeat procedure 4 and 5 until you get the optimal solution. Now we start. Determine the variables of the problem. So from the problem that we have read, these are the variables. Let x1 be the units of fresh milk manufactured per week. 2. Let x2 be unit of soy milk manufactured per week. Determine the objective function. How do you get that? We said the objective function will be z is 3x1 plus 4x2. The profit to be maximized. So our equation as far as objective function is concerned is maximization, not minimization. Determine the constraint function. How do you get that? We say 2x1 plus 5x2 is less or equals to 24 hours times 5 days per week. 2 equation 4x1 plus 2x1 is less or equals to 16 times 5 days. So this is the nature of the constraint that we have, and whereby x1 and x2 must be greater or equals to 0. Converting the constraints into equality. So we do the conversion, z equals to 3x plus 4x2 plus s1 plus s2. These are constraints. 2x1 plus 5x2 plus s1 equals to 120. Equation 2, 4x1 plus 2x2 plus s2 equals